my division symbol. Yeah, the top part. So the 2x cubed minus 13x squared plus 26x minus 24. And then the bottom piece on the left-hand side. And then we look at the first two terms. How many times, let's look at just the numbers, how many times does 1 fit into 2?
2.
Twice. Okay, so we need a 2. And then we also need x cubed divided by x. What's
squared?
Yeah, x squared. Remember, we subtract those exponents. We take this 3, we subtract off this 1. Now we take the 2x squared, and we multiply it by our entire divisor. So 2x squared times x is 2x cubed. We double check, we make sure that this matches. If it doesn't match, we did something wrong. And then 2x squared times negative 4 is negative 8x squared. And then we subtract, and we're going to be really careful for double negatives. These cancel. This is negative 13x squared minus negative 8x squared.
Negative 5. Or no,
Yeah, negative 5x squared. Negative 13 plus 8x squared. So negative 5x squared. We finished round 1. We drag it down. We reset. We start round 2. Same thing, how many times does 1 go into negative 5?
5.
Negative 5 times. And what should my exponent on x be? 2 minus 1. 2 minus 1. Just 1. So we have 5x. Again, we can kind of check ourselves up here. Your exponents should be decreasing. Then we take the negative 5x. We multiply it by the x minus 4. So negative 5x times x is negative 5x squared. We check to make sure it matches. Negative 5x times negative 4 is positive 20x. We subtract. 26 minus 20 is 6. Drag down your 24. Last round, how many times does 1 fit into 6? 6. Do we need an x term? Nope, so just plus 6. 6 times x is 6x. 6 times negative 4 is negative 24. And for our remainder, we get 0. So what you're going to put into Delta Math or box on your test is this top piece right here, that polynomial 2x squared minus 5x plus 6. Let's do one more. The next one's a little bit faster. Again, we put the larger polynomial on the inside of our bracket, or on the inside of our division symbol.
Bless you.
But what else do I need to add for this polynomial?
0x2.
Yeah, 0x squared, my placeholder. I don't have an x squared term. Let me make one up. Let's make it 0. And then still plus 4x plus 23. And your x plus 8 on the left. We do the same thing. The 1s are fine. 1 fits into 1 time. What should my exponent on x be up here? 3. 4 minus 1 is 3, so x cubed. We multiply that to each piece. X to the 4th plus 8x cubed. This one's kind of weird, and I think some in your homework last night did this too. But this term cancels, and this term cancels. And we could pull down a 0, but it's not going to help us at all. So the next two terms that we really care about are these two at the end. Everything else before that is 0. 0, 0, 0. So this is what's left. And then to get from x to 4x, we have to multiply by 4. So we put plus 4 up top. And then last step, multiply that 4 back in. We would get 4x plus 32. And our remainder would be 23 minus 32, negative 9. And then our last step is actually putting this back in as a polynomial. Yeah, Jackson, we'll get you caught up too. Don't stress too much about it yet. But our actual answer here is the polynomial on top plus, what should I do with that remainder of negative 9? Perfect, over your divisor. So over the thing that we divided by. Okay. Questions on either of those or anything from yesterday? Okay. Today is no more long division. We're doing something called synthetic division. So, synthetic division is, again, you'll probably like it more. It's a little bit easier once you get used to it. But we can only use it when we divide off linear polynomials, meaning we're dividing by something that is x plus or minus a number. Or you could also have like a coefficient in front of your x. So we could also have something like this. But the key here is the exponent on x in the thing that we're dividing by is 1. If we're dividing by an x squared, we can't do this version of division. We have to do long division. So all of our divisors today are going to look like this. X is going to be to the first power. And here's how you do it. You take your divisor and you solve for x. You set it equal to 0 and you solve for x. So if we set this, x minus k, equal to 0, what would x equal? Positive k, yeah. That number is what you're going to stick in the box. And we'll talk about the actual setup of this in a second. But you got to find this number first. What does x equal when you set your divisor equal to 0? Then you line up all of your coefficients. So you put them at the top. We're going to start actually doing these steps for this polynomial down here. So let's look at our divisor. If I set this equal to 0, what does x equal? 4. Okay. I'm going to stick 4 in the box. This is the box. On the left-hand side at the top of your work, put a box or half of a box, and you put the number 4 in it. You also, in the setup, have to list out just your coefficients. So we don't need the x cubes and the x squareds anymore. We just want the numbers. For synthetic division, if you miss a placeholder, your entire problem will actually be messed up. So you have to put those placeholders in. And we'll do a lot of examples that require placeholders, but just double check, make sure you're putting your placeholders in. So if we look at these coefficients, my first coefficient, what is it? 2. And then negative 13, 26, and negative 24. Again, those are just the numbers in front of each of my x terms. And again, we're looking at these polynomials in standard form. So if this was like an x squared out here, we would want to rearrange to make sure our coefficients are in the right order. Okay, so that's step 1. You set this up. Step 2 is you bring down your first coefficient. This is going to be like an equal sign down here. So you bring it down. Step 2, and this is where it's kind of similar to long division. We take this number, we multiply it by the box number, and we stick the product in the next slot. So 2 times 4, we stick it right here in the next column. We put 8 there. For long division, we were doing subtraction a lot, and we were dealing with double negatives. For synthetic division, we're doing addition. So instead of subtracting, we're doing negative 13 plus 8. So that's why it can be a little bit easier as well. There's no double negatives that you have to worry about. So negative 13 plus 8 is negative 5. We put it underneath. We repeat that process until we get through our last column. So negative 5 times 4 is negative 20. We stick that in the next column. We add 26 plus negative 20 is positive 6. We multiply 6 times 4, 24. And then negative 24 plus 24, 0. This last number in the corner also gets a box. That last number is your remainder. Always. So whatever number we get here, that's your remainder. Everything else is going to be the coefficients of your new polynomial, of your answer. The tricky part is we have to figure out what term is first. Do we have an x to the fourth, an x cubed, an x squared? Well, let's look. My term here, my degree of this polynomial is 3. And we took away a degree 1 polynomial. So how many degrees are left? 2. And that's always going to happen. Whatever degree you started with for synthetic division, you take 1 away, and that's your new degree of your polynomial. So my terms, this one's going to be an x squared term, so 2x squared. This will be a linear term, negative 5x, and this is my constant and my remainder. So my answer, 2x squared minus 5x plus 6. And that's it. If I had a remainder, I would do the exact same thing with it that I did for long division. I would take my remainder and I would put it on top of the thing that I divided by. That was just the first one, so it's okay if it's going over our heads a little bit. We're going to do some more. The next one. We're dividing by x plus 4. So if I set that equal to 0, what number should go in my box? Negative 4. Perfect. You flip the sign. So we put negative 4 in the box. Now I look at my coefficients. What's my first coefficient? 1. There's a 1 in front of this x to the 5th. What's the next coefficient? 0. I'm missing an x to the 4th term. So I need a 0. My next coefficient? Negative 15. What comes after that? 0. I'm missing an x term. Or sorry, I'm missing an x squared term. What comes after my 0 x squared? 0 for my x term. And then my last number? 2. So again, make sure if your degree is 5, the amount of numbers that you have here should be 1 more than that. It should be 6. Because we have our 5x terms and then we have a constant term. So 1 more than your degree. And then we get started. We pull down the first number. We multiply. What number should go here? Negative 4. We take this one, we multiply it by negative 4, we stick it in the next column. Then we add 0 minus 4, or 0 plus negative 4? Negative 4. Same thing, that's the end of round 1, or the end of round 2, really. We take negative 4 times negative 4, 16. We stick it in the next column. We add negative 15 plus 16, 1. We multiply 1 times negative 4, negative 4, and we stick it in the next column. We add 0 plus negative 4 is negative 4. We multiply. What number should go here? 16. Negative 4 times negative 4. So 16. We add. We get 16. We multiply 16 times negative 4.
Negative 60.
Very nice. Negative 64. And then we add again, and we get negative 62. And we box this last number because it's special. What's the last number mean? It's our remainder. Okay. So let's label that as our remainder. And then let's label the rest of my terms. I started with x to the 5th. I got rid of 1. What should go here? X to the 4th. So x to the 4th, x to the 3rd, x squared, x, and my constant term. And then we just have to write out our polynomial. 1 x to the 4th is just x to the 4th. Minus 4 x cubed. Plus 1 x squared. Minus 4x. Plus 16. And then my remainder, what should I stick this on top of? Not on top of negative 4, the x plus 4. So that's something that you kind of have to watch out for. For long division, we just stuck this over the thing that was outside my division symbol. This time we actually have to go back up to the problem and divide it by what we divided by during that division. Okay, give me like a thumbs up, sideways, down, how we're feeling so far. This is a lot more thumbs up than we had yesterday. Do you think it's easier than long division? I agree, but if you don't like it, that's okay. You can do any of these problems with long division too. But let's do some more. I'm going to talk about, we're going to skip the middle two. Actually, do the middle two with the people around you real quick. Try those out for me. We'll reconvene and come back to them in a second.
So that exponent has to be 1. All of these have an exponent of 1. Okay. So we solve. We stick that number off to the side. It looks a little bit different up there. You can do your boxes, whatever way you want. I do that because it's faster. Okay. Okay. Stick it inside. Okay. You're going to write out all of the coefficients. Those numbers in front of your x term. You just write it out in order. Okay. And you put placeholders if you need to. So if you're missing a cube term, you can zero. Okay. And you drag down over some. Take that number. You multiply it by this number. You stick it in the next column. Okay. You add. Multiply again. Going around one, multiply. You stick it in the next column.
So you go in order. If there's not like a, so you have to go 3x.
Next column.
Well, no, it doesn't matter about that. It's just the fact that
Do
you
you
have.
see the pattern here?
Yeah, there's no 3
Multiply,
squared right here,
and then
and
you're at,
there's
yes,
no
exactly.
x
That's
factor
exactly.
right here, but
Okay.
there's no x.
Then,
1.
down here, this last number is your
So
remainder.
like, look,
So that works
see how I
out
split
like
it to 0 because it fills in
These other
x
numbers, though,
cubed.
are the coefficients
3.
of your answer.
Negative 2 has
So
it's
if we
squared,
took this
but
exponent,
there's no like,
and we divided off
there's not a number like this.
my new
There's not a number like
first term is
3x.
x squared.
There's not a
It
number
went
like
from
there, so you
3,
have to fill it in
got
with
rid of
zeros.
1, we get a 2.
Okay, so then here you just get rid of this. No, that's just, that's what you're dividing by. That's why this is this.
constant term,
Yeah.
there's no x attached. Okay. Here's the easier part. You look at the number that you started with up here, we have x cubed. You just do x squared instead, take one away. And then x squared x constant, or x cubed x squared x constant. Okay. It'll always go in like that kind of order. And that's your answer. Okay. You stick those numbers in front of those terms. That at least gets you more than just starting out a blank piece of paper. Here we're adding, so 41. Okay, not perfect. Perfect.
Check mine too.
1 plus 40, 41. But that's good. And negative 135. Negative plus negative is smaller. But good. Not good. Synthetic division, also FYI, is a lot faster for me to check because I only have to look at your remainder. Everything else had to line up if you get the same remainder as me.
Wait, What'd you get for your answer?
Negative 6 times negative 2 is positive 12. So I guess I did say you don't have to worry about double negatives. You do for the multiplication part. That might still happen. But you won't ever subtract a negative.
Why is this name like 3?
Is it not?
No, you just
Oh my god, yeah, I forgot about
You
that.
always take or a longer. Oh, you got the synthetic.
They didn't take anything inside. So much stuff in my locker.
Good. Good. Also, FYI, you're coming after school, right?
Or,
Okay.
but do you have off 8 hours? Like, I'm ready, I just went off of working and didn't have to be there.
Well, that's what I was gonna offer. My last class of the day is my dinner period.
Okay, I have student aid, so I think.
You come to me 7th hour.
Okay, no,
That's even better. Perfect. Oh wait, 8th hour?
Yeah, 8 hours.
Oh, never mind. I thought you meant your last hour today. 8th hour, I don't
Oh.
have.
Oh.
I have 6 or 7.
Oh, crazy.
Oh my gosh.
All right, let's do these together. It looks like we're kind of wrapping up. What number should go in my box? What number? -2. It's the opposite of whatever's up here. Then I look at my coefficients. My first one's 3. What's after that? What comes out? You guys all did it on your paper. What number's after 3? Am I missing a term here? 0. Okay, I'm missing a term. Thank you. Okay, what's my next number? -2. We need another 0 for my x term that I'm missing. And then 1. And then we do our process. We drag it down. We multiply. We get -6 over here. We add. I lied to you a little bit. I said you're not dealing with double negatives. I meant subtracting a negative. So you might have double negatives for this multiplication to make it positive. So positive 12. We add. We get 10. We multiply. We get -20. We add. We multiply to get positive 40. And then we add to get 41. Oh, okay. Okay, now, this term right here, this 3, should it be in front of an x squared, and x cubed? What do we think? X cubed, it's always 1 less than the thing that you started with. So 3x cubed minus 6x squared plus 10x minus 20 plus, what does 41 go on top of?
X plus 2.
X plus 2, the thing that I divided by. Perfect. The next one. What number should go in my box? -5. Okay. Then I look at my coefficients. My first one's 4. So 4. 3 goes to 2. So my next one's 15. What comes after 15? 0. I don't have an x term, so I need a 0. And then minus 10. We drag it down. We multiply. We get negative 20. We add. We get negative 5. Multiply again. Negative times a negative is a positive 25. We add. We get 25. We multiply. We get negative 125. And then again, a negative plus another negative gets us more negative at negative 135. Then we look at our coefficients. X cubed was what we started with, so what should go here? X to what power? Squared. 4x squared minus 5x plus 25. And then my remainder divided by the thing that I divided by. Synthetic division is usually a lot faster than long division just because you're adding. It's just quicker in your brain. What's up?
When you're writing the remainder, can you just write minus 135?
Yes, yes. Careful though if there's like something else up here. If this is a polynomial. Careful with doing that because you have to distribute that negative. So that's why I just say plus whatever. Nick? Yes. Okay. When we divide by x plus or minus a number, it's nice and simple because we just take the opposite of this number and we put it in here. Sometimes we're dividing by something that looks like this. We have a number in front of that x term. Nothing crazy really happens. We just have to tweak our answer just a little bit. We're going to do the same thing. We're going to solve for x. We're going to go through the whole process. But when we're done, we're going to take our coefficients, and instead of just sticking these into a polynomial, we actually have to divide all of these coefficients by that number in front of x. Okay? So it's that same process. But don't forget to divide these by this too. So let's see what that looks like. If I solve this, 2x is equal to 3. If I add 3 to both sides of this when it's equal to 0. So x is equal to 3 halves. We're going to deal with fractions. You will have access to a calculator. I'm going to show us how we can do it in our head. So, 3 halves goes in my box. My coefficients get lined up on the top. I'm not missing any, so I can just write them as I see them. And I do the same thing. I drag the first term down. Basically, every time you do this with a fraction, your denominator is going to cancel out when you multiply it by this number. So if you're putting fractions in here, double check your work. That probably won't happen. So like here, 2 times 3 halves, my 2's cancel. I just get 3. Let's do that out here. 2 times 3 halves is the same as 2 over 1 times 3 over 2. Cancel, cancel. We get 3 over 1, which is 3. Fractions are crazy. Yeah. Then we add. We get 8. Let's do some mental math again. 8 times 3 over 2. If I just do the 8 in the 2 part, what am I left with? 8 divided by 2? 4. So that cancels and it becomes a 4 times 3. And we get 12. It's not too bad. Fractions aren't terrible. Then we do negative 2 plus 12 is 10. We do the same trick. 10 divided by 2. 5 times 3. 15. And we get a remainder of 0. Now, sometimes it's... Sometimes you forget to divide by this coefficient. If you have a fraction in here ever, you have to divide these by something. So we're dividing all of these by 2. That includes your remainder as well. Yes?
Do you always have to divide by the denominator?
Yes. It's always by the denominator or always the number in front of x. Yeah, so if that helps you, we divided by 2 here. So we're dividing by 2 here. So our new numbers, 1, 4, 5, and 0. So our answer, we started with an x cubed. So what term should this be? X squared. So we get x squared plus 4x plus 5. And that's it, because our remainder is 0. So it works the exact same way. At the very end, though, there's one extra step. Let's do it again for the next one. At the very end, what number am I going to be dividing by?
2.
2. Okay.
Wait, Miss Cruz.
Yeah.
Will you always be dividing by that number next to x?
Yes. The number next to the x or the number at the bottom of your fraction in your denominator. It's always going to be the same. So we're dividing by 2 here when we're done. If we solved for x, what would x equal?
1/2.
Negative 1/2. We would subtract that 1 over. So negative 1/2 goes in my box. And we start filling out my coefficients. 4, 16, negative 23, and negative 15. Something else to just be aware of, because it's in your activity in a second. Even if you don't have a constant term, you still have to put a placeholder for your constant term. So if we just had this, we would have to put a 0 here to fix this missing piece. Okay? So we drag down the 4. We cancel things. 4 divided by 2. 2 times negative 1 is negative 2. We add. We get 14. We multiply 14 divided by 2. 7, and we make it negative. We add negative 30. Divide by 2. 15, negative 15, and then we make it negative again. So positive 15. And then we add and we get a remainder of 0. Then I divide by what number? 2. And I get my new coefficients. 2. What's my exponent on x going to be down here? X squared, so 2x squared plus 7x minus 15. And that's it. These are the hardest ones that you'll see, is something with a number in front of x. Okay? That's it for our notes and everything. So, we do have homework, but we're going to do an activity before I give you homework. It's not even that bad. You don't even have to get up. Find a partner. You can do this by yourself if you would like, but find a partner and one person in your group or yourself, raise your hand. You can move around if we need to, and you can totally be by yourself. Okay, what you are getting is a worksheet. If you are by yourself, your job is to just do one of the columns. That's your only job. If you are with a partner, you will each do a column, and you're going to check yourself as you go. You and your partner's answer for number 1 should be the same. So don't move on from number 1 until you get the same answer as your partner. Use one sheet per group. Just do it on a whiteboard or a piece of paper. So you have 5 extra problems before we do our homework. So grab a whiteboard or an extra piece of paper. If you're by yourself, for sure. If the partner ones, it's kind of hard to. But yeah, go ahead. And if you are by yourself, feel free to check with me as you go. And partners, check each other. Nope, you can do just all that side or all this side. Pick. Do you think it's harder? It's different.
It's different, so I just have to, I think I've got it though.
Once you process and realize you're not subtracting anymore, yeah.
So where is the, so it's this line that gets divided by 2?
Yes.
And then these are the coefficients from that, right?
Yeah, so like this is what we got from this
That's
piece.
from that part.
We divide by
and
2.
then divide by 2, and then that's your new answer.
Yes.
Okay.
Yes. So again, Chromebook should be away. You should be doing this worksheet by yourself or with a partner. And then you can do your homework. So get a whiteboard or right on the other half of that, but check AJ as you guys go. Your answers should even though they're different problems.
You got 7.
That's okay, keep going.
No, they're not.
You're adding now. So 60. Oh yeah, 60. Yeah. It's right, you're good. Also, none of these should have a remainder. So if you get a remainder, all right. Try again.
Oh, Ms. Cruz, may I have one of those sheets, please?
Yeah. Yeah. Keep going. Just do half of it. Just do one, like a column. Do 1 through 5 on one side there.
Mr. Cruz, just put the answers inside the box after we write it on the whiteboard.
Yeah, you don't have to, I'm not collecting this worksheet, so you just check yourself, make sure you're good. Yes, none of them should have a remainder. Did you get the remainder? Oh, 7 times -5, 35. Yeah.
No, you multiply negative positive 2. Wait, is it
Just grab this little guy here, because I ran out of tissues. No, all set.
What do you get in now? The test is not that.